So I have just one word for you, or maybe it's 2 words, I don't know, doesn't matter. Anyway, that word is microservices. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia, as usual. And when is it? It's August 2021. Now I hope wherever I find you, and whenever I find you, that I find you happy, safe and well. So yes, this is the big one. This is microservices. This is the course that I have been wanting to make for such a long time. And now it's finally here, free on YouTube. It was a lot of hard work, it was a lot of fun, but I'm glad it's done. Now, you will see from the timestamp that it's a long video, so I wouldn't expect anybody to go through it in one sitting. So with that being said, I have put the time codes in the description below. So that means you can jump to the sections that you want to go straight to, or you can come back and pick up where you left off. That being said, I do suggest you go through it start to finish for the best experience. Now, I have tried to put in the right balance of content for an introduction to microservices, but if you do have any feedback on how I can improve, please put that in the description section below. I always love getting your feedback. One last thing, just a big thank you. Thank you for joining me here on YouTube. And if you do like the video, please think about giving it a like. That just helps me out. And if you've not done so already, maybe think about subscribing, ding the little bell, and that way you'll get notified when I make new content. And finally, to my Patreon supporters who go that little bit extra and support me on Patreon, thank you so much to you. I cannot tell you how much I really do appreciate it. And as usual, as a way of thank you, your names are coming up at the end of the video. That's enough for me. We have got plenty to get through, so I don't think we should delay any further. And I think we get started. All right, so yes, welcome to this step-by-step course on .NET microservices, and we will also be using Kubernetes, RabbitMQ, and gRPC. So up front, I just want to, this isn't the course outline, we go through that in a second, but what I want to be very upfront about is just the approach we take in this course and the type of approach I've taken, which may or may not suit some people. So I want to be very clear about that up front before you invest too much time going forward. So this course will focus on the technical aspects of building .NET microservices, which shouldn't be too much of a surprise. So hopefully that's why most people are here. We'll cover the theory as we go, but I wanted it to be as practical and as technical as possible. And so we do theory, but I didn't want to do so much theory up front that it becomes maybe a bit tedious. So we cover it as we go, but there is a bit of a theory block up front as well. Take a pragmatic, balanced approach, but always try to follow best practices. But again, you do have to balance that. When you are developing in the real world, it's not a highly theoretical place, and you sometimes have to make tough decisions, pragmatic decisions on how best to go forward. So again, I've taken that approach in this course as well. It's fully step-by-step, so the code is available on GitHub, but I don't point you to a repository and just tell you to download code and point at it as part of the video. We actually go through every single bit of code step-by-step, line by line, and that goes for doing Kubernetes stuff as well. So that might not suit some people, I'm just calling it out, but that's the way I've approached it here. It is fully step-by-step, and that's why it's pretty long. Already covered this, be as practical, as interesting as possible, but also acknowledge that microservices are hard and they don't solve every problem in the world. So we do have to go into the course acknowledging that that is the case, and I certainly try and acknowledge that. Some things this course doesn't do, so I don't focus on things like domain-driven design, bounded context, a lot more of the kind of highly theoretical stuff about how you would design your business-focused microservices. I don't really focus on that. We touch on it slightly, and I make the point about, services should be bounded, for sure, but I don't go into lots and lots of slideware or theory about that. We don't build out too much redundant business logic in our example. Our example is incredibly simple. Well, it appears incredibly simple. There are only 2 services, and you might think that's not enough to learn anything. Believe me, it is more than enough to learn the basics and the introduction introduction material to microservices, more than enough. And I felt if I introduced more services and tried to build out something like an e-com app, it would detract focus on really what I was wanting to try and get across. So we don't focus on redundant business logic about building carts and category pages and all that kind of stuff. Don't demonize the monolith or bandwagon jump. There are reasons and scenarios when you would definitely use a monolith and reasons where you would definitely not use microservices, which is probably the same thing. And I call that out and I give some examples of why we do that. So what I'm saying here, what I'm not trying to say here is that microservices don't cure everything. They're not the best approach in all circumstances, definitely not. And we don't cover everything. There is a balance to be struck, of course. You're never going to cover everything, and I certainly haven't covered everything here, but what I do feel I've done is given enough material that's going to give you a really good introductory foundation to building microservices with .NET technologies and all the associated stuff around that. I feel this course is going to give you that really good introduction foundation that you'll need to move forward. Okay, let's go through the course overview. So just FYI, there are 9 sections, 9 parts to the course, so we're just going to go through those now. So the first part is our introduction and theory, so we go through course overview, which we're doing now. Some prerequisites, which aren't mandatory, but kind of nice to have. The ingredients and the tooling that you'll need if you want to follow along. We then move on to some theory, so what are microservices, why you would choose to use them. We look at monoliths and why you would and would not use them as well. We then look at our services that we're going to build out. We do an overview of our solution architecture, and then we look at our service architecture, so how we're actually going to build our services out. We then start the practical build, and the rest of the course is fully practical from this point on, so it's all coding, config. So we start the platform service, which is our first service. So a bit of an overview of what it is. We scaffold it out, build out the data layer, and then we work on our controllers and actions. Part 3, we look at Docker and Kubernetes, so a review of Docker. We containerize our platform service, so we build it as an image and push it up to Docker Hub. We then go into Kubernetes, what it is, why you would use it. We look at the architectural overview of our application in Kubernetes, so that's the Kubernetes architecture section, and then we deploy our platform service into our Kubernetes cluster. And then finally in that section we set up some external networking so we can actually use our platform service inside of Kubernetes. Part 4, we start with our commands service, but really this section is focused on synchronous messaging actually. So we scaffold up our command service to start with, we set up a controller and action, and then we look at messaging, synchronous and asynchronous messaging. And as part of the synchronous messaging, we set up HTTP communications between both our services, our platforms and command services. So as part of that, we add a HTTP client to our platforms service. We obviously have to deploy our command service into Kubernetes. We do some internal networking, and we also stand up an API gateway. So it's a really big section where we cover an awful lot of material. Part 5, we move on to SQL Server. Every service has its own database, so this is the SQL Server for our platform service. As part of setting up SQL Server, we talk about something called persistent volume claims. We look at Kubernetes secrets. We deploy SQL Server to Kubernetes, obviously, and we revisit our platform service. And just a quick call out, if some of this stuff you don't know what it is, that's fine, we cover it all in the course. So if you don't know what a persistent volume claim is, do not worry about that, we obviously cover it in the course. Part 6, we revisit our command service and we talk about multi-resource REST-based APIs. So we review all our endpoints for our command service, we build out our data layer, and then we finish off our controllers and actions. That looks like a short section, but it's actually quite a long section. Part 7, we then look at our message bus, which is RabbitMQ in this case. So we do a review of our solution architecture. We give an overview of what RabbitMQ is. We deploy RabbitMQ to Kubernetes and we test it. Part 8, we then start to really build out our asynchronous messaging using RabbitMQ. So that involves adding a message bus publisher to our platform service. We look at event processing, and then we add an event listener to the commands service. And then to round out the course, we look at gRPC, so an overview of what gRPC is, why you would use it, all that kind of stuff. We'll do some final networking configuration inside Kubernetes. We'll then add a gRPC server to our platform service. we create a proto file or a protobuf file, and then we add gRPC client to the commands service. And to round it off, we deploy all that and we test it all end to end. All right, so let's move on to the course prerequisites. Now again, these are just suggestions. We do everything, as it says, they are fully step-by-step, but some of the stuff is quite complex. And if you've not touched it ever before, you might find some of the concepts a little bit heavy going. So I do have courses for all this stuff, pretty much, on the channel. So if you're a bit rusty, maybe you want to brush up on the following. So experience with building .NET Core REST APIs. So I have a full course on my channel that covers that in detail, although we do it again here step by step as well, but I do spend more time on bits and pieces in that video. Understanding of Docker and associated concepts. Again, if you've never touched Docker before and you don't even know what it is, we do cover it here, but again, doing a more detailed course might help you out. Dependency injection in C# would be useful. Again, we do cover it here, but some of my other courses go into it in a lot more detail, the more sort of basic theoretical concepts. And if you've used async and await before in the C# language, that would definitely be useful. But again, that's probably not super critical. So all of this stuff would be useful. We do cover it all step by step. But again, if you've not ever built an API before using .NET, C#, you might find some of the stuff a bit challenging. All right. So these are the ingredients that you're going to need if you want to follow along practically, which I think most of you probably will want to do. So I'm using VS Code text editor. You can use Visual Studio if you want, but again, I'm deciding to use VS Code. I just find it lighter and more adaptable than Visual Studio, but you can use Visual Studio if you want. .NET 5 is sort of mandatory. There's some concepts in here. If you decide to use an earlier version of the framework, you may run into some little niggly problems, so I highly recommend you run with .NET 5. You will need Docker Desktop running Kubernetes, again, which is free. An account on Docker Hub, again, which is free. So when we push images up to Docker Hub, you obviously need to have an account to do that. And you'll need either Insomnia or Postman, which are basically API test clients, which we will be using throughout the course to test our services. And in this video, I'm running everything on my local hardware. I did have a decision to make on whether to go with this approach, running everything locally, or whether to go with a cloud provider like Google Cloud or Azure. I decided that this course would be using just your local machine, so you don't have to sign up for cloud services, which I know doesn't suit everybody. But the downside of that is, yes, we will be running up quite a number of services, so you do need a decent level of local hardware. So I'll just show you my PC spec, just out of interest. Now this is probably a higher spec than you need, but I'll just go through what I've got anyway. So yeah, we'll be spinning up a lot of containers in Kubernetes, which obviously has an impact on your local hardware, most especially memory, really. So I've got an Intel i7, I've got 32 gig of memory, which is probably way more than you need. In fact, it is definitely way more than you need. It's just what I happen to be running. 16 gig will be absolutely fine. So 16 gig, you should be totally fine. Anything less than 8, I mean really 8 is probably the minimum, the absolute bare minimum, and I think even if you're running 8 gig, you're probably going to struggle a bit with that. So between 8 and 16, I'd recommend 16 to be honest with you. And the hard drive is sort of irrelevant, but I just happen to have a 1 terabyte solid state disk drive, but it's really the memory. Memory is the main thing that you will need. So yes, 16 gig, you should be fine. Now, the other thing I want to call out is we are doing a lot of Kubernetes stuff in this course, so I have produced a free cheat sheet that you can download. It's a nice one-pager that you can refer to, so either on screen or you can print it off, and it has all the Docker and Kubernetes commands that we're going to be using in this course. So it's a nice little one-pager reference guide. It has our Kubernetes application architecture reference on there, so again, you can kind of tick off what we complete as we move through the course, and we also have a Kubernetes object glossary. So again, if you're new to Kubernetes, we cover it all in the course, but again, everything that you see on screen here is on a nice little one-page summary for you to download. So all you have to do is go to .NETplaybook.com, that's my blog website, and just register for our mailing list, and we will subscribe to our mailing list, and we'll email you with a download link. And I do want to call out that we never, ever, ever pass on your email address to anybody else. In fact, I hardly even use the mailing list at all. I probably send out an email maybe once a year or something, and I definitely do not pass it on. So just be assured, if you do give us that, it's totally secure and we don't ever pass it on to marketeers or anything like that. Other course resources, the code is available on GitHub for you to download and follow along. There is a lot of code here, there's a lot of scope to make errors, and I've made a few errors as I've made the video, which you will see if you follow along. Don't worry, I do correct them, but it's always nice to have that backup of a code repository so you can refer back to and compare what you've done. In the description of the video, I have put timestamps to all the sections, all the main sections in the course, so it's a very long video, so I don't expect anybody to go through it in one sitting. So the course outline description, in the description, you can jump to each section and come back and revisit at your leisure. And then finally, the course slides, the stuff that we're going through. There's quite a few slides that we're going to go through. I'm not making those available publicly, but they are available to my Patreon supporters. The $5 supporters and above can download the course slideware through my private GitHub repository. So if you're interested in that, maybe check out my Patreon site at the following address. All right, so let's come on to talking about microservices now. We've done enough introductory stuff. So what are they? And rather facetiously, I'm saying, how are they saving the world? Not being totally serious when I say that. So let's look at this idea of a single responsibility principle, which was coined by this chap, Robert C. Martin. And what he's saying is, gather together those things that change for the same reason and separate out those things that change for different reasons. So what did he mean by that? Or what do we mean by that? Well, that really is a nice way to kind of, at a high level, think about microservices. So what are they? They are small, okay? They are built, let's say, by a team that would consume 2 pizzas. That's a way that we often measure team size. So imagine, at the end of the sprint, end of the week, you want to treat your team to pizza. You only need to buy 2 pizzas to satisfy this team. So small team. Or if you want to think about it and how long it would take to build a typical microservice, you're looking at maybe 2 weeks to build. That's what we mean by small, although that is quite a subjective term. They are responsible for doing one thing well. So you kind of have this idea of a microservices application, which will include many, many different services. Each of those services will do one thing and do it really well. Okay, so again, go back to that single responsibility principle. If something is doing one thing, does it really well, it doesn't need to rely too much on the other parts of the system. Although paradoxically, in order for it to be a microservices application, services typically will talk to each other because they need to share data between themselves. But you don't want it doing so much sharing that they're chatting to each other all the time. So that's why breaking down your services into doing one thing and doing it well is really important. They're organizationally aligned. So think of a large organization. The parts of that organization will typically be responsible for running and managing a set of different services, and they have almost exclusive control over those services. So they can change them when they want to, and they can make additions to them and take them down when they need to. And other parts of the organization, they will have their own set of microservices that are aligned to their part of the business. And again, they will need to, or most usually, they do talk to each other. This is really important. So again, we will talk a lot about decoupling and the fact that you don't want services talking huge amounts to each other, but at the same time, again, paradoxically, in order for it to be a full microservices solution, the services typically form part of a distributed whole. So one service doing one thing by itself, never talking to anything else, is that a microservice? Possibly it's not, okay? It really is a true microservice when it does form part of this larger distributed system. And again, this is we've already kind of covered this, self-contained, autonomous. So again, they are responsible for doing one thing. They can stand on their own without being too reliant on other things. All right, so just to help position what microservices are, let's look at the contrasting side of things and look at monoliths for a bit. Now, you might be wondering what a monolith is. So probably the best way to describe it is by reference to an actual system. Now, the system I'm going to describe here is actually an amalgamation of a number of systems that I've worked with or been across at various points in my career. But one thing is definitely, for sure, if you work in a large organization, there's a very, very strong chance that you have a system like this in that organization, in your organization. So this is a sort of example of something that I have come across on my travels. So a large monolithic CRM system that services millions of customers. So it's a really, really super important system. Evolved over many years. So again, it's not something that's been stood up within the last 6 months. It's been around for many, many years in an organization that itself is many, many years old. Built on a single proprietary technology stack. So obviously there'll be different technologies that make up the monolith, but for the most part, it will be built on one platform, one tech stack. And in this case, and in most cases, it will typically be managed by an outsourced partner, so it won't even be managed by the organization itself directly. Most usually, or a lot of the time, systems like this are managed by third parties. So what's wrong with that? Well, this system is very, very difficult to change. It's a huge code base. Making changes even to a small part of it, you have to make sure that it hasn't impacted any other part of the code base. So change cycles are months in duration, and even for big migration projects, if you're maybe migrating from one monolith to another, they can be years and years in duration. But for this particular one I'm thinking about, the change cycle was at least 3 months. Lots of testing, often frequently manual testing to make sure that nothing has broken when you make changes to these systems. So difficult to change and therefore very slow to change. Difficult to scale. Now, what I mean by that is, the CRM platform is a huge system. And let's say, for example, you are going to experience increased orders at certain points of the year, say, near holiday periods or something like that, or, Black Friday sales or something like that. You may want to try and scale the part of the system that just deals with ordering, and all the other parts of that system don't need to necessarily scale as much. But with a monolith, you can't do that. You have to scale the entire system. So quite difficult to scale specific bits of the system. You can scale it, but it means you have to scale absolutely the whole system, which makes it quite inefficient to scale. And then finally, you're locked in. You've got one big, huge platform. It's locked into the technology stack, pretty much. Very, very difficult to change the technology stack. And also, if you're using an outsourcing partner, you're locked in from an intellectual property perspective as well. So this one party knows everything about that platform, which is fine, but you can't then choose another party to manage that system. Well, you can do, but it'd be very, very difficult to do so. So you're kind of locked into that vendor managing this platform. It's not a great situation. So this brings us on to the benefits of microservices when you kind of contrast that with that example monolith. Definitely easier to change and deploy, basically because they're smaller and they are more decoupled. Can be built using different technologies, so you're not locked into the one technology stack. Typically, different teams will build different microservices, and it's really up to them to choose what technology they want to use to build those microservices. So long as they can talk to each other, the services, it doesn't really matter what they're built with. You have increased organizational ownership and alignment. So the CRM system, there'll be many different parts of the business that are relying on that system. And if one part of the business wants to change it, another part of the organization may not want to change it, or they may have their changes that they want to prioritize over the other part of the business. So it becomes this headache of managing priority, managing change, whereas with microservices, typically each part of the business owns their own services, and so they can change them and prioritize their own changes till the heart's content, really. Resilience. So we'll see this with an example in a minute. One service can break, that's fine. The other services will continue to run. Whereas with a monolith, if the monolith goes down, typically the whole thing will go down. So you'll end up with this situation with microservices where parts of the system may be down, but other parts will continue to run. And I've got an example coming up. And scalable. So coming back to this issue of scalability, with a monolith, you can scale it, but you have to scale the entire thing. So it's rather inefficient to do so. With microservices, you can focus and scale out just the services that you need to scale. You don't need to scale everything. So it's much more adaptive to different demand patterns. And they're built to be highly replaceable and swappable. So that's the whole point of them. If you are not happy with a particular service, you can replace it with another service built by the same team or possibly built by a different team. But the whole point is that they can be swapped out. You're not locked in. All right, so let's come on to an example of a relatively simple microservices application that kind of talks to some of the concepts that we've just mentioned. So let's say we have an airline and an airline has decided to go with a microservices architecture. You could split your application up as follows. So you would have could have a flight catalog service. So that's the service that contains all the flights that people can book. And let's say, for example, in this example, it's written in .NET with a SQL Server database. And we have, in this case, one running instance of that service. And it's built by a team, let's say, based in Scotland. We then have a second service. This is the booking service. So let's say, for example, it's built using Ruby on Rails. It has a different type of database, PostgreSQL database. We have one running instance and it's built by a team in the USA. And what you'll see here, which is quite obvious, is that each service has its own data store. So the flight catalog will use its own data store and the booking app will have its own data store. Now, these services will more than likely share information, and that's really what the whole of this course is based around, is how do these services share information that the other one relies upon. But one takeaway is that they do not share the same database. They may share data, they will not share the same database. And it comes back to this whole point that one of these instances can go down, the other one will continue to run pretty much uninterrupted, possibly with some limitations. And then to round out our airline example, we'll have a check-in service. So somebody uses the flight catalog service to browse flights. They will then use the booking service to book a flight. And then finally, at the airport, they will check in, or they can check in online. So they all have different domains. They may be run by different parts of the business. Our check-in service in this case is written in Node. We have one instance and it's using a MongoDB. So again, to labour the point, it has its own data store and it's written by a team in India. So the takeaway from this slide is that separate services written by different teams, they have their own database and they will be somewhat reliant on each other. So for example, you won't be able to check in unless you have access to booking details. And again, the whole point of this course is to understand how we can move data between services, but they are independent. So for example, if the booking service went down, people can still browse and look at the flight catalogue. So they can still go online, they can still see what flights are available, they just can't book. And likewise with check-in, people can still go to the airport or they can still check into their flight online. They might not be able to book a new flight, but they can still check in. Or let's say the check-in service goes down, people can still browse flights and they can book flights. They just can't check in. So the point of this is that even though one of the services may go down, the others remain up, and certain parts of those operations that they are responsible for will continue to run. Unlike a monolith, where the whole thing goes down, everything goes down. And of course, what we're going to explore in this course is the fact that even if a service does go down, we'll be able to recover them much, much quicker. The other thing is to talk about scaling. So let's say this example airline has a sale on and we have lots of people coming to the website to look at flights and book flights. You can scale out additional instances of those services. And the check-in service, you leave untouched because the number of check-ins probably isn't going to change unless you maybe increase the number of flights. But let's say in this example, the number of flights remain the same, but we have a run on cheap flights that this airline is running. And you can scale up and scale down your instances very, very easily. So that brings us on finally to say, so does that mean everything about microservices is awesome and everything about monoliths is completely terrible? Absolutely not. And on this slide, we have some disadvantages of microservices, or certainly some things to consider when you use microservices versus using a monolith. So microservices are difficult to implement. There's no getting around it, they are difficult to implement. Writing an individual service might be somewhat okay, but designing and building an entire microservices architecture is difficult. When you're starting out, especially with a greenfield site, microservices may not be the best approach because if you don't understand the problem domain, you may spend most of your time just analysing the best way to break down and compose your services. And you may end up just in this analysis paralysis where you end up not building anything and you just keep going round in circles trying to determine what microservices you should be building. So yes, you need strong domain knowledge. And so in a greenfield site, that may be difficult. Microservices are distributed. So that's something that people tend to forget about, and when you're running, in a development environment, you're not really taking into account the fact that these things necessarily are running over a network. So you can have services running in different geographies that rely on the network. And of course, the network can fail or it can slow down. And so that's something you really need to take into consideration when building microservices. And paradoxically, we keep going on about this concept of, microservices are totally decoupled. Well, as a paradox, they still need to be coupled to something. A microservice that doesn't talk to anything else is probably not actually a microservice. It's maybe a mini monolith or something like that. So yes, you want to reduce lots of chatty messaging between services, but ultimately, in order for them to function as a microservice architecture, they need to be coupled to something, even if it's just a message bus or the database, or more than likely other services. So the good things about monoliths: simpler to implement, no doubt simpler to implement, at least initially. You still can use CI/CD, daily deploys, you can do small changes. So the example I gave of a monolith, it was a huge beast of a system, and you were unable, just given the history of that application, to have a CI/CD type pipeline, do daily deploys, all that kind of stuff. But you can absolutely do that with a monolithic system, assuming that you build it in the right way to begin with. So one of the advantages of microservices is, you can use an agile approach to deliver them, and that's absolutely true, but it's also true of monoliths. So just because it's a monolith doesn't mean to say that you cannot deploy changes daily for a monolith. You absolutely can, but you have to make some considerations and build that application in a particular way, but it is still absolutely possible. Building a monolith is also a great exercise in familiarizing yourself with the domain. So again, especially if you're like a startup or something like that, and you don't really know your domain that well, and you don't even know if your organization is going to be around next year, spending thousands and thousands of dollars building a microservices application where you don't really know the domain may be absolutely a terrible idea, and you may end up spending half your time, just trying to analyze the problem. Whereas if you just go about and start building a monolith, number one, it's a bit simpler to implement, at least initially, and it also is a great exercise in familiarizing yourself with the problem domain. And so if you're one of the lucky startups that actually does start making money, then that's fine. You can then possibly move to a microservices architecture at that point. But at least if you've taken this approach and gone with a monolith to begin with, you're probably going to get up and running much, much quicker. And also you're going to start to understand your domain. So when you do come to actually implementing microservices, you'll probably compose them in a much more efficient way. And you can still have 2 or 3 big services. So this is kind of like a hybrid type approach, I suppose. You might not have microservices where you've got tens or even hundreds of services. You may end up just having 2 or 3 big, maybe not services, but 2 or 3 big applications that each don't do just one thing, but kind of take care of a bunch of stuff that's kind of similar. So it's a kind of halfway house sort of approach, and that may work well for some people. And generally speaking, monoliths won't be as reliant on the network as a microservices application. They're typically not considered distributed applications, so you do not have the same considerations around network latency or even network being unreliable as you would with a microservices application. All right, so let's come on and take a look at the services that we're going to build in this course. And we have 2 services that we're going to build. Now, our first one is the platform service, and that's what we will refer to as throughout the rest of the course. And it's basically going to function as an asset register for our fictional company. So it'll be used to track all the platforms and systems in our company. Now, we're not building out a full asset register system, just to be upfront with you, but we are going to build our platform service to operate in that way. But that is the idea behind it. And most importantly, it's built by the infrastructure team. So this particular team, they have a strong interest in maintaining a running asset register of all the systems in the organization. All right, so let's come on and take a look at the 2 services that we're going to spend our time building as part of this course. And we have two services that we're going to build. So let's move on to the first one. And this is our platform service. Now, what is the platform service? Well, the idea is that it's basically going to function as a sort of asset register. So it's going to contain all the systems, all the platforms that our fictional company is running. So yes, as it says, they're used to track all the platforms and systems in our company. And it's built, in this case, by one team, the infrastructure team. So may not be called infrastructure team in your organization, but maybe you might call it the operational team or the ops team or even the DevOps team. So that's the team that build it. That's the team that's owning it, and they will more than likely prioritize their changes against it. But it's not just to say that they're the only team that will use it. Yes, of course, they will use it, but it may be used by the technical support team systems. So again, faults are raised. You may want to know what system you are raising a fault against, and the technical support team will more than likely consume data from this service. Engineering team may want access to it for similar reasons. The accounting team, they may need access to it just to understand the assets that we have in the organization and what we need to write down each financial year, all that kind of horrible stuff. And even procurement. The procurement team may be interested in data that this platform service provides when it comes to renewing licensing agreements or signing new contracts, all that kind of stuff. So yes, owned by the one team, built by the one team, but will be used potentially by many other teams. So our second service is the commands service. And what is this? The command service basically is acting as a repository of command line arguments for given platforms. So the idea is it's going to aid in the automation of support processes. So imagine the concept where you may need to restart systems in a particular way, or you may need to understand how to back up databases in a particular way, rather than memorizing reams and reams of different command line snippets for different types of platform. This service is going to contain a repository of all those command line snippets. And so built by the technical support team. So this is the team that's going to build this repository. They're going to run it and support it, and they are going to be the principal users of it. So used by, the technical support team. May also be used by the infrastructure team, may be used by the engineering or development team. They may have an interest in getting access to this as well. Now, one thing that's going to kind of recur through the course is the fact that I have the word platforms on this slide, and that's no accident. The command line service is somewhat reliant on the platform service, and getting that platform's data into the command service is one of the things we're going to focus on as part of this course. But takeaway, two separate services can theoretically or should be able to run completely in isolation of each other, even though there is somewhat of a dependency between the two of them. All right, so let's come on and take a look at our overall solution architecture. So this is kind of the 50,000 foot view of what we're going to build. Now, this does not reference Kubernetes or any Kubernetes type objects just yet. When we come on to doing Kubernetes, I kind of overlay all the kind of Kubernetes concepts on top of this view here. So this one is abstracted away from that, and it's really just the components that we're going to build or use. So with that being said, first service we're going to have is our platform service. It will have its own SQL Server database, and together that kind of forms the entire microservice. It's basically going to be a REST-based API. So the public interface, the interface that our consumers are going to use, is a REST-based API. And yes, this service sits within what we're calling our internal microservices domain. Now we can theoretically access that API directly from externally into our internal microservices domain, and we will do that just while we're developing. But ultimately, we're going to use this concept of an API gateway, which is really going to front up all our services. And so any external requests coming in are going to then get routed internally to our relevant services. And so in this case, you can see our API gateway is routing through to our platform service using its REST API. Then our command service, it's going to have its own unique database just for it. Just for quickness, we're not going to stand up another SQL Server. We're just going to continue to use the in-memory database. But the important point to note is that it's absolutely got its own database. It does not share a database with the platform service or any other services for that matter. And it too is a REST-based API, and it too will make use of the API gateway will route through to our command service. So taking a look at this now, it's all great and everything, but is this really a microservices architecture? To be honest with you, I would argue and say that at this point, looking at the screen at the moment, I would say this isn't really a microservices architecture. Mainly because the platform service and the command service are completely and utterly, totally unaware of each other, which you might say is a good thing, but there's no data sharing between the two in any way at all. They're really just totally separate apps that happen to go through an API gateway. So again, there is a paradox here. You do want to have services decoupled. You do want to have them independent, but at the same time, you don't want them so independent that they don't talk to anything else. That is the paradox. So in order for it to be a microservices application, in my view anyway, there needs to be some degree of data sharing between the two. And that brings us on very nicely to looking a bit more at our command service. So what you can see here is a snippet of what the database may look like. And you can see that we have a list of command line snippets, how to do a particular thing, such as stop a service or restart services or generate migrations. And you'll see that we have those command line snippets. But most importantly, you'll see that our command service does rely on the fact that it needs platform information. So for the majority of this course, what we're really going to be concerned about is trying to understand the best way of getting platform data from our platform service down into our command service. Now, as we've said before, the command service cannot reach into the platform service database, absolutely cannot do that. One approach possible would be that we kind of couple quite tightly the platform service to the command service. And what I mean by that is, once we create a platform in the platform service, we could theoretically get the platform service to post using HTTP to the API of the command service and say, here's a new platform that I have created. This does create quite a tight coupling between these services though, because the platform service absolutely has to know where the command service sits. And that does kind of create this concept of a coupling. So really what we're going to focus most of our attention on in this course is the idea of using asynchronous messaging via an event bus or a message bus. And so what we're going to do, similar sort of scenario, when we create a new platform in the platform service, we're going to publish an event onto our message bus. Now, all the platform service is aware of at this point is the fact that there is a message bus. It is not aware of the command service, nor does it care that there is one. And in this case, what we're then going to do is we're going to get the command service to subscribe to the message bus and receive those platform published events, and then it will add those platforms to its own database. So this idea of creating data in one service, in this case a platform, and it subsequently making its way down to other services is something that we call eventual consistency. Again, services don't share the same database, but they do need to share the same data. And so the main problem that we're really looking at here is how do we make sure that all these services have all the data that they need and data that may come from other services. So in this case, we're going to use a publisher-subscriber model, synchronous messaging to get that information down into our command service. And again, to labour the point, the platform service does not even know that the command service exists. And again, we're only going to do 2 services as part of this video, but as you can see here, you may have other services that publish other events onto the event bus and subscribe to other events or similar events. And you can see again that the XYZ service has its own database, the ABC service has its own database, so on and so forth. So you have this decoupled architecture, event-driven architecture, which is really what microservices are about. So to round out our solution architecture, we are going to make use of gRPC, and gRPC is used quite a lot in microservices, so for that reason I've included it. And what we're going to use gRPC to do is allow our command service to reach out to our platform service and pull down any platforms that it doesn't already have. But the point to note about gRPC is that it is synchronous, it's not event-driven, and so we are coupling our command service to some extent to our platform service. Okay, so let's move on to taking a look at our service architecture. So again, we'll look at the main components that make up both our services. So we'll start with our models, our internal data representations. We'll have a DB context, which mediates those models down to our persistent layer, in this case SQL Server. We're going to make quite extensive use of data transfer objects, DTOs, which are external representations of our model data, and they're mapped, as you can see there, to our models. And we're also going to make use of a repository pattern, which just abstracts away our DB context implementation. We're going to have our API REST controller, which is I'm calling synchronous in. So HTTP requests coming in, we'll say externally, reach into a repository, pull back any data, and then send back the HTTP response using a DTO. So that's really our external contract going out to our external consumers. We're also going to have a HTTP client, which is, I'm calling here synchronous out, and it's going to make HTTP requests to our, in this case, command service and receive back a response. Now, I'm including this just for completeness, just as an example. We're not making extensive use of this, but we are going to build it out just to demonstrate that particular approach. We're then coming on to the main event, which is to use a message publisher, which is asynchronous out. And so our platform service, yes, is going to publish events onto our event bus, onto our message bus. And then finally, we're going to use gRPC within our platform service as a synchronous in service. And so clients, in this case our commands service, can use gRPC to request platforms back from our platform service. And we're using gRPC to do that. Now, an important point to note, the only external interface here is our controller, our HTTP Web API controller. Everything else that is not denoted by a green line is internal within our microservices domain. And as you can see from the darker coloring on the publisher, it's asynchronous, the other ones are synchronous. So command service architecture, I'll just go through these quickly, it's exactly the same. Again, this is exactly the same. We're going to have a controller, synchronous in, responding to HTTP requests and giving HTTP responses. We're going to have a message subscriber. So this is asynchronous in, so it's going to receive messages from the message bus. And we're going to have a gRPC client, synchronous out. So this command service is going to make requests to our gRPC service in our platforms service. And again, the only external interface here really is our Web API controller, right, REST API controller. And with that, I think we start coding. All right, so I'm going to come over and we're going to start to build our platform service. So I'm just going to start a new Visual Studio Code window, and I think it's probably started it on my other screen. Indeed it has, so let me just pull that over. Rather annoying. Now I've got my screen running at 150% magnification, so hopefully that's large enough for everybody to read clearly what's happening on screen, but at the same time balance that it's not too cramped for writing code. So I might change it if it's not, if it's a bit too cramped, but I think this is going to be okay. So I'm going to bring up the integrated command terminal by doing Control and back quote, and then change into my working directory. Now this will be, chances are something different for you, but for me it's on my D drive and it's season 4 and then it's episode 3. Do a quick directory listing and it's empty. Now we're going to create a few projects in here as our main sort of solution folder, but for the moment let's just work with individual projects. So the first one we are going to set up, now actually before we do that let's just do a .NET version, --version, just to check the version of .NET that we have installed, and it's version 5. I would strongly suggest you use version 5 and not 3.1, which probably will work, but you might have to make some tweaks here and there to get it working, so go with version 5. All right, so I just did a CLS to clear the screen, and we're going to do a .NET new. Web API is the template type that we want, and then we give it a name of platform service. And I'll just make sure I've spelt platform and service correctly. Looks like I have, so hit enter. And that will go away and scaffold that up for us. So quick directory listing will confirm that that is the case. So I'm just going to do a code, open this recursively, and I'm going to open this folder up. So platform service. And that will open our project up for us in Visual Studio Code. Now, I'm assuming that you are somewhat familiar with web APIs in .NET. As I say, if you're not, then I would suggest you check out one of my other videos that I've put links in the description below to. We'll just click yes to this, and this will just create a .vs Code folder, just so it remembers our settings and so on and so forth. So I'm going to delete the weather forecast class. It's just like a class that's used by the templated project. And I'm also going to come into controllers, and I'm just going to delete the weather forecast controller. Fantastic. And then you should be familiar with the regular anatomy of a Web API project. And we've really only got a controllers folder now empty, but don't worry, we will be populating that relatively soon. But the first thing I want to do is really just start to add in our dependencies, our package dependencies that this service will require. So again, I opened up my start menu there. So control and back tick to get the integrated terminal up and running. And I like to leave the platform service CS proj file up and running. So as we add packages, you'll see them being added to this file, just to make sure that we've not made any typographical mistakes. So the first thing I want to add is .NET add package, and the first one is AutoMapper. And I'm actually just going to copy the package name from my notes over here because it's a little bit long-winded. There you go. So it's automapper.extensions.microsoft.dependency injection. And I'll hit enter. I'm sure you don't want to see me typing that in. And you can see it's been added as a package reference to our CS proj file. And then the next one, .NET add package. And again, I will save you from my typing because I'm sure you don't want to see me type out some rather long package names. This one's a bit shorter though. Microsoft Entity Framework Core, which of course our database context class will be using to communicate to initially our in-memory database and then subsequently our SQL Server database. But we do need a few more packages in that space. So I just did upkey, so .NET add package, Microsoft Entity Framework Core design. You need that one as well, and that's just at design time. This does not get included at runtime. And then the last one in the, well actually no, it's not the last one, we got two more to go. So Microsoft Entity Framework Core. We are initially going to use an in-memory database because it's just a lot simpler than connecting it into SQL Server, but we will of course use SQL Server eventually. But yeah, we do need Microsoft Entity Framework Core .in-memory. And then the last one in this kind of Entity Framework Core is of course SQL Server. So Microsoft .entity framework core .SQL Server. And I think that's us good for now. So you can see that there was one other package in there, the Swashbuckle. That just gives us an open API spec out the box, which is quite nice. We might take a look at that later if I remember, but for now, we're going to leave it at that. Now we are going to add other packages, but I'm not going to put those in just yet. I'm going to wait till we come to the relevant section and then we'll add those in. I'll just have to make sure that I do remember to do that. So for now, that's good. Our application is scaffolded up. We've included our packages, so now we are going to move on to adding in our model. All right, so back over in our project, we're going to create our first model, well, in fact, our only model for this service. So in the root of our project, I'm just going to right click and do new folder. And I'm going to call the folder models. Although we're only going to have one of them, doesn't matter, use that naming convention anyway. So right click on the models folder and new file, and the model is going to be called platform.cs. So it's just a plain old C# class. And this is really our internal representation, our application's internal representation of our data. Why am I saying that? Well, we go on to use data transfer objects in a bit, which are basically our external view of our data going out. So models internal, DTO's external. All right, so namespace, which should be platform service. And then we'll do models. All right, and then the name of our class is just a public class is platform. And this is probably going to attempt to autocorrect. No, it didn't. Great. That's it. So it's public class, and then we're going to add some properties to it. So to sort of shortcut writing properties, if you type prop and then tab, and then you can tab through the property that it's created. So yes, this instance, we do want an integer, so tab over, capital ID to give us our model ID, and that will eventually become our primary key down in our database. Next prop, so again prop, tab is this time is string, and it's just going to be called name. I'm only going to do a few properties here. Next property will be another string, and I'm going to call this publisher. Okay. And then the final property, and we're not really going to use this, but I just want to labour the point. I'm going to create another property, just make it a string for simplicity, but I'm going to call it cost. Now, while that's a bit of an ambiguous property name, the point here is that for this service, you might want lots of properties that describe the platform. So cost might be how much it costs, or it might be its annual subscription, or it might be a support cost, or it might be the cost to run. And you could add all these in, as well as lots and lots of other properties very specific to this domain, to this microservice. It's a platform service, it's an asset register. You might have loads of attributes in your platform model that you might want to have there. Spoiler alert, we're going to have like platform representations elsewhere in our microservices ecosystem, in our commands service specifically, and it's just not going to be interested in that type of data. So the point I'm making here is, yes, you're going to have this concept of a platform that permeates throughout our system, but different services will have different views on what that actually means for them in terms of the context of what they're trying to achieve. Okay, so a bit of a long-winded way to say that you could have loads of stuff in here that other services just may not be interested in when they come to modeling or representing this type of data. Cool, so let's just save that off. And then the only other thing we want to do, just to help Entity Framework along a little bit, is just decorate these with some annotations. Now, the first one I'm going to use is the key annotation, just to say that this ID is going to be a key in our database. So make sure your cursor is in the offending article. It's got the little red squiggle under it. Make sure your cursor's somewhere in there, and Control and period to get Visual Studio Code to give you some code suggestions. And I'm going to select the first one here using System Component Model Data Annotations, and we'll add that in the top for us. Now, we're going to be doing that control period about 1 million times, well, not 1 million times, but a lot throughout this course. I'm not going to say it again, although I'll probably mention it again, but that's how you get those code suggestions up. Now, just a word of interest. By default, Entity Framework Core would interpret this property as a key. You don't really technically need to specify that it is a key, but I just like to do it just to be a bit more complete. And it also acts as kind of in code documentation, although it's not really documentation. This is similar. This is not actually required because a primary key is of course mandatory, so you don't really need to have the required attribute, but I just like to put that in because, well, I'm maybe a bit weird. And then I'm going to make all these other properties required as well, so they cannot be null. All right. So that's it. It's a very simple class, and you might be going, that's a bit too simple. Believe you me, you don't want it to be any more complex because there's a whole lot of other complexity coming down the line, so we want to keep it relatively straightforward and relatively easy to understand. Cool, so that's our model created. We'll move on to the next section, which is looking at our DB context. All right, so the next thing we want to do is create our DB context. So again, just we'll pay a quick visit to our architecture. So we've created our model, just a platform model. We're now creating our DB context, which effectively maps our models down to our persistent data store. Now, to begin with, we're just using an in-memory database, but we will move to SQL Server eventually. So this is the next thing that we're going to tackle. So back in our project, new folder in the root, and I'm just going to call this data. I'll put a few data related things in here and right click and new file, and we'll call this appdbcontext.cs. And then namespace is just platform service.data. And it's just a public class called appdbcontext. And we're going to inherit from the base DB context class. And it's probably going to try and autocorrect here, but let's see how we go. Yeah, it did. So just go back and take that back out and just say we're inheriting from DB context. So we want to bring in that namespace, so control period, using Microsoft Entity Framework Core. Fantastic. And then we just want to create a constructor that we can, if we need, pass in additional options if and when we need them. So constructor, actually short code for constructor is ctor tab, and then you can just tab through, and we're going to pass in one parameter, which is DB context options of type oh well, whatever our class happens to be, so DB context. And we'll just call that OPT. And we can get that from base. Okay. And we don't need to put anything in there just yet, but that's our constructor, that we'll use for this. And then most important, well, it's as important, we need to define a database set, a DB set, and which relates to our model. So that's really what's telling our DB context to mediate or mirror our internal model down to the database. So we just specify a property, prop, tab. This time it's of type DB set. And the type of DB set is platform. And we'll complain, so control period, bring in the namespace for our models. And we just want to call that platforms, plural, okay? So that's our DB context class set up. Then what we need to do is we need to kind of register it over in startup. So let's do that now. And in our configure services method, we want to add that in here. I'm just going to take these comments out because the code looks busy enough at this level of magnification without additional redundant commentary. So yeah, we're going to put that in configure services, which is where we register all our services. No surprises there. So I'm just going to add that here, services, add DB context. What type of DB context are we going to add? Just the class that was added in the last section. And it probably won't find that, so we'll need to bring that namespace in. Control period using platform service data. Fantastic. And then we'll just specify some options. And we're going to tell it what type of database we are wanting to use. So we're wanting to use in mem database. And I don't think it's finding this. I think we've probably got to bring back, yeah, using Microsoft Entity Framework Core. Let's bring that back. And let me take a new line on this just so you can see that a bit clearer. And then you just give the database a name. It can be anything, it doesn't really matter. I'm just going to call it in-mem. So we are using our DB context with an in-memory database. And again, we will move to SQL Server and we'll make some determination in here, a bit of a check to see whether we're using a development environment, which I'll still use the in-memory database, or when we move to production to Kubernetes, then we will use SQL Server. But we can leave that for the moment. We just want to get up and running with our DB context. And that's it for our DB context. So in the next section, what we're going to come on to doing is we are actually going to work with a repository. So we're going to start to set that up in the next section. And really what I want to try and do is get all this blue stuff kind of set up, this data stuff set up before we move on to the more interesting stuff. Not that this isn't interesting, but we get all this wired up and then we can move forward. So repository next. All right, so back over in our project, what I'm going to do is I'm just going to get rid of this terminal for the moment. It gives us a bit more space in our on our screen. And yeah, we're going to create a repository now, and we're going to use the interface concrete class pattern because we will inject our repository through dependency injection in our startup class. But if you don't quite follow that, don't worry, we'll do it step by step anyway. So the first thing we want to do in our data folder yet again is create an interface. And an interface basically just specifies what type of things, the method signatures effectively that our repository will support, and then any concrete class can come along and implement those interfaces. So yes, over in our data folder, right click, new file. And because we're defining our interface first, we will specify a capital I, and I'm just going to call this platform. There we go. You're just going to do it eventually. Platform repo for repository.cs. Not repi. That sounds like it's Latin there. I did it again. Repo. All right. I platform repo.cs. Okay. And namespace of platform servers and data. And it's just a public interface called I platform repo. And then all we do in here is specify this method signatures effectively. So the first one, and if you've done any Entity Framework Core stuff before, you'll realize what this one is for. But basically, we need to save any changes that we make. So whenever we add stuff to our DB through our DB context, adding it or deleting it is not enough. You actually have to save those changes. So we'll need to put something like that in here, which is what that is. And you'll see how that works when we come on to doing the concrete class. And then the first kind of proper signature that I want to define is getting all our platforms. We want to be able to use our API, use our service to retrieve all platforms. So specify it as an enumerable, which we don't have the namespace for. So enumerable of platform, a platform class, or platform service. And we'll just call that get all platforms. We're not going to pass anything in. So quite a simple operation. So bring in using system collections generic for the IEnumerable, and then we'll bring in the, try that one more time. Using platform service models, there we go. Okay, so this interface should allow us to get all platforms, specifying it as an IEnumerable. Next one we want to do is just return an individual platform. So not an enumerable this time, just returning a platform, and we'll call this get platform by ID. And this time we will pass something in, which will be the identifier of the platform, the ID of the platform, the unique ID. And then the last one is we want to be able to create a platform. So just make that void, call it create platform, and we will pass in a platform object into that method. And then we'll have to call save as well when we come on to doing that. But that's basically our interface done. These are the three, or really four, but these are the three things that this interface should provide somebody that's choosing to use this interface. And now what we need to do is we need to build out an implementation class of this interface. So we'll do that now. So again, in data, right click, new file, and we'll just call this platform repo.cs. So over here in namespace, create namespace, and we'll call platform service, data, fantastic. And then we just specify it's a public class called platform repo, and it's going to implement iPlatform repo there. Okay, and straight away it will complain because we've not actually implemented any of these methods here. So again, our best friend, put your cursor in there, control and period, and click implement interface. Now it's not clever enough to actually fully implement it. All it does is create these placeholder method definitions, and then you can just see it's just throwing a not implemented exception. So yeah, it doesn't fully implement it, but yeah, it gives us the placeholders that we need, which is good enough. And actually you wouldn't want it to implement it anyway, because generated code is not that great, but this is fine. All right, now before we come on to doing that though, we want to actually create a class constructor, and this is our first use of our first proper use of seeing how dependency injection works. So again, ctor to create a shell constructor, and what it's going to expect to be injected in is an instance of app db context. And we'll just call that context. Okay, so whenever we use platform repo via our interface, when it gets constructed, it's going to expect an appdb context to get passed in. And because we have registered our appdb context here in our configure services method, that will occur. Okay, so I'm not going to go too much more about that. I would expect you to be somewhat familiar with dependency injection, so I'm not going to explain it further than that. But we'll use it so much throughout the rest of this course that it will definitely become second nature to you. And then to finalize, we actually need to make use of this context that's injected in, so we do that via a private field. And the convention is to typically start these with an underscore. Well, I do anyway, and you'll see it used a lot like that. So basically, whatever's injected in here will get assigned to this. And again, this doesn't exist, so control period. And what you want is this one here, generate read-only field. And I'll put it up here for us, private read-only appdb context. And you'll see this pattern used time and time and time and time and time again throughout the rest of this course. And that's really dependency injection in a nutshell. So we can come on to working with our methods down here. So I'm going to start with the simplest one, and we'll do save changes. So let's just get rid of that for the moment. And all we want to do is return, and we're going to make use of our DB context, and we're going to say save changes on that context. And then this little bit here is really just saying if the result of save changes is greater than 0, then we basically return true back. So we had something that changed. So that's all that is. And we'll call this after any create, update, or delete operation. Any unsafe operation that we have on our data source, we will have to call that to make sure those changes are flushed down to our database. All right, so let's start with this next one, which is getting all platforms. We'll do that one next. And it's really quite simple. Return, again, we'll make use of our injected context. And then on this, you can see that we have our platforms object available, and that is just coming from, that's just this property here. We're just referring to that now. So we're going to return platforms to list. And I think we'll probably have to bring in the link namespace here. Yep. So control period using system link. It puts that in at the top for us. Fantastic. And that's all we need to do for that. We'll come on and do our get platforms by ID, and it's slightly more complex, but not much so. So return context platforms, but this time we're going to use this first or default method to say give us the first instance of a platform, or the default one, and then we're going to specify some criteria using a lambda expression. So we'll say P goes to P, and we're wanting to find the ID of the platform where it's equal to, I'll get rid of that prompt, where it's equal to the ID that we pass in. So quite straightforward. We're basically saying, yeah, return everything from platforms, what the first or default item, excuse me, from platforms where the platform ID equals the ID that we passed in. So it's conceivable that we get nothing. It's conceivable we get a null return there, but nonetheless, that's okay. And then finally, well, we've done that one already, haven't we? And then the final one is creating a platform. So first thing we want to do is check to see that we've had some sort of valid object passed in. So we'll just do a fairly simple if plat equals null. Then we don't want to do anything. So actually I probably shouldn't have deleted that throw statement, but we'll just type it in again, throw new argument. Actually puts a slightly different exception, argument null exception, name of plat. Okay, so that just gives us a more descriptive exception, and we'll just bring in that namespace using system. So if platform is null, if it's not been defined and we're trying to create one, then we'll just throw this exception. Otherwise, quite straightforward. Context, platforms, add, and then we just add the platform object that we've been passed in. Fantastic. Now when we come to use this, as I've said before, we'll then need to call save changes to flush that down to the database. And that's it. That's it for our repository, and that's actually it. We're not going to change this now. That's our finalized repository, and that's our finalized app DB context. So the next thing that I want to do, and just before we do our DTOs, is kind of create a little class that's going to prepare our database. So when our app starts up, I want to actually put some data, some mock data into our database, just so that we have some there to work with. And when we come on to using SQL Server, I want to also run what's called migrations to actually create the data structure in the database. With the in-memory database, you don't actually need to run migrations, which is kind of good, but kind of bad. The other thing I will say about the in-memory database that we're using now is that it really is only used for test purposes. It's not a production type database. And of course, because it's in memory, if the service restarts, you'll lose all your data. So it's really, can't stress it enough, probably should have mentioned it when we were setting up our DB context, is really just for, it's really not even used much in development environments. It's really just used for testing, really. But we're making use of it here just because it's going to get us up and running much quicker than setting up databases. So we will eventually move to SQL Server though. So yes, anyway, what we want to do next is prepare our database, put some data into it. So we're going to create another little class to do that, and then we'll come on and finish off with our DTOs before we move on to writing up our controller. All right, now actually just before we go on with creating our database preparation, one thing I forgot to do, having created our repository interface and our concrete instance of a repository, one thing I didn't do is actually come over and register that for dependency injection, so that when somebody asks for an interface, a repository interface, we give them whatever concrete class we specify. So the way we do that is just over in Configure Services, and we'll just make use of services again, and we're going to add a scoped service, and we will just say if somebody asks for iPlatform repo, we're going to give them platform repo. Cool. So yes, obviously very important when it comes to using dependency injection, we register our interface and the concrete implementation of it in Configure Services. So somebody asks for this, we give them this. Fantastic. So let's just save that off. The one thing we've not done so far is build. So let's just bring up our command line and let's just do a .NET build. There's not much to run yet, so we'll just do a build. I mean, it should be okay. We'll run it once we've kind of come to the end of this sort of section of data stuff. So that's all good. So I just want to do that, make sure we're okay to go. So yes, next what we're going to move on to is creating a class to kind of prepare a database with some example data. Okay, so just back over in our project, I'll just close down our startup class and give us a bit more space. And yes, we're going to create our database preparation class. So over in data, just right click, new file, and we're going to call this prepdb.cs. And then we'll begin with a namespace as usual, platform service.data. And this is a public static class with the name of prepdb. Get that round the right way. And yeah, static class, we don't need to create instances of it. And this class is going to have two methods, one public and one private. And the public method is going to set up a database context for us that we can use. Now, this isn't a constructor, this is just a public method. So you might be going, wait a minute, got a couple of questions here. Why aren't we using constructor dependency injection? Great question. Well, we can't because it's a static class, so we can't use constructor dependency injection. And the second question you might have is, why are we using a DB context? Why don't we use the repository that we just created? And that's another great question. So the reason I'm using a DB context in this case is that eventually I'm wanting to use this class to generate migrations in our SQL Server database. And it's just much easier to do that directly on a DB context. All right, and there's a couple of other methods that we're going to use here that I don't really want to build into my repository anyway. This class here is really more for testing. This is not something I would probably push into production. It's really just for us and for this video to help us set up things in our database environment. So that's the two reasons. We can't use constructor dependency injection, and I'm using a DB context mainly because I want to use it eventually to create some migrations. All right, so with that being said, let's create our first, let's create the signature for our first public method. So it's public static void, and I'm going to call this prep population. Now, before we define what we're going to pass into it, if we come over to our startup class, we're going to call this method, this prep population method on this class from startup. So once we've run configure services and then configure starts to get run, we're going to call it in and around here. And what we're going to pass in order for us to be able to use a DB context is this iApplication Builder instance here. We're actually going to pass this through into it, and then we're going to use this to create something called a service scope, which we can then use to create a DB context. So it's a little bit heavy at this stage in the course, and it's slightly off topic, but we have to do it, and I'm just trying to explain it as best I can. So hopefully you'll follow the code. It's not that bad, but let's get on with it. So yeah, we need to pass in an instance of this to this method over here. So let me just code that up now. So iApplication Builder. And we won't have the namespace for this, obviously, and we'll just call that app. So what I'll do is I'll just bring in the namespace for that, and I think I probably spelled it wrong. Yeah, there we go. Application Builder. Let's try that again. There we go. Using Microsoft ASP.NET Core Builder. So that's a good tip. You know, if you're doing the control period thing and you don't really see what you want, chances are you've spelt whatever it is wrong. Okay. Fantastic. Now, just before we continue with this, what I'm going to do is I'm going to pop over to our startup class, and I'm going to just call this method, because we've got everything we need now that startup needs in order to know about it, and call it, just so I don't forget. So prepDB, we can access the class directly because it's a static class, and then prep population, and we're just going to pass over app. All right, and that's all we need to do in our startup class, so I'm going to save that off. So back over into prepDB, we will carry on with this. So yeah, as I was saying, we need to create like a service scope in order to derive a DB context. So I'm going to do that via a using statement. So I'm going to create, first of all, a variable called service scope. I'll make that equal to using our app, application services, and then create scope, which I don't think will be available to me just yet, so I'll have to bring in that namespace. So control period, that's the one we want. Microsoft extensions, dependency injection. Fantastic. Now in here, we're actually going to call our next method, our private method, which is the method that's going to do all the seeding of our data and eventually run our migrations. So let's just create the method signature for that. So it's a private static void method called seed data, and this is going to expect an app DB context, and we'll just call that context. Okay, fantastic. So where is seed data going to get an app DB context from? Typically, if this was a normal class, it would be via constructor dependency injection. You can't do that, as I've said, so we're going to have to create an instance or call this method, this private method, with an instance of AppDB context from within our first method. So let's do that now. So let's call seed data, and then let's give it the DB context it so desperately desires. And we do that by making reference to the service scope we've just created upstairs, using service provider, and then get service. And any ideas what service we want to get? Of course, AppDB context is what we want to push in there. And don't forget the round brackets at the end. We can close that off with a semicolon. So this public method, that's it, it's basically complete. So now for the remainder of this little section, we're just going to fill out the seed data method that we're going to use to, in this instance, just pass in some data. As we're still using the in-memory database, we don't need to worry about migrations. We just need to pass in some data. We will come back and update this though when we move to SQL Server. All right, fantastic. So let's move into here. Just make sure I'm indented in the right place. So the first thing I want to check to see if we have any data in our database relating to platforms at all. So we'll make use of our context, and we will just look at our platforms instance, and that's, if you come back over to AppDB context, we're just referencing this here basically. And then we can use this, probably have to bring in link here, but we can use this any syntax to see. There we go, we're getting autocorrect because we don't have link reference, so let's do that now using system link. Yep. So if the context platforms has anything or doesn't have anything, so make sure you put in the exclamation mark, so it's a not operator. If we don't have anything, then we want to push data in. Okay, otherwise you do nothing. Now I'm just putting this else statement in really just to help us with a bit of output, a bit of debugging output. So I'm going to do a console, and I'll bring in the system namespace, so control period using system, console write line, and I'm just going to say we already have data. And that'll come in useful when we actually use SQL Server and data will be persisted. At the moment, most of the time, we're always going to be seeding data at startup because we're using in-memory. And if once we shut something down and restart it, all the data's gone anyway. So for the moment, we're never going to see this. We're only going to see that when we move to using SQL Server, but we'll put it in for the moment. And then likewise up here, I'm just going to put in a console write line, and we'll just say something like seeding data. just so we know it's kind of working. All right, so now we'll come on to actually putting some data in, and there's another nice method we can call on our platforms object, on our context. So we'll use that now. So context, platforms, and then we can use this method called add range. And it's quite nice because it allows you to add a number of objects at once, which is quite nice. All right, so we're going to create a few new platform objects to pass in and create. And remember, DB context works off of the model, the platform model, nothing to do with DTOs. This is all internal to our platform. So new platform, I'm just going to bring in the namespace. I think I brought in the, used the fully distinguished path, which I don't like. I'd rather bring the namespace in up at the top. So we're going to create, yes, a new platform, and then we simply just specify a new platform. So name equals, first one, let's do .NET, why not? Put a space in there. We'll specify the publisher, which in this case would be Microsoft. And we will then specify the kind of rather ambiguous cost attribute. I'll just say it's free. All right, now I want to create a few more. Now, rather than watching me type those out, I'll just go over to my notes and I'm just going to copy in a couple more. And you can, of course, put in as many as you like here. You don't just need to put in 3 like I'm doing. There we go. In fact, let me get rid of this thing at the side. So Control B to take away the panel, gives us a bit more space. So nothing too controversial. We're just creating a couple other platforms, SQL Server Express and Kubernetes. Don't forget the commas at the end of each line, except for the last one. All right, so that's cool. We've added our products to the database effectively. Do not forget, and I always forget this, do not forget to context, save changes. Because yes, that add range will add stuff to the database, but unless you save the changes, it's not going to go in there. Right. So that's it for the moment. I think that's it for the moment anyway. PrepDB is done. It's going to start up, give us a database context, and add that to our database. So why don't we give that a go now? We did add the call to this method here in startup, so it should be good to go. So Control / to get a command line up. Let's do .NET build, just to build it first. Although when you run it, it builds it, but I like to do the build before the run. I don't know why. .NET run now. So what we should see is this seeding data message. There we go. I think it flashed up on screen. Quite quick though. Yeah, seeding data. So cool. It's realized we don't have any data in our in-memory database and it's seeded the data. Now we can't do anything with that now. We can't access it yet. That's when we come on to our controller. Fantastic. But what we're going to move on to now, just to kind of round out the data section, is look at DTOs. We're going to create some DTOs. We'll do that next. All right, so back over in our application, I'm just going to kill our running server, Control C, and get rid of this terminal. So yeah, we're going to come on now to DTOs. Now, before we start coding, just a little bit of a sense check by reviewing our architecture. So we've created our model, our platform model. We created our DB context. We have an in-memory database. We will move to SQL Server at some point, and we spent some time creating a repository, which our other classes are going to make heavy use of. But just to round out this kind of section, we're going to now move on to DTOs, data transfer objects. And what are data transfer objects? They're basically external representations of our internal models. And you might be going, why do you want to do that? Well, you don't want to expose your internal models to external consumers. Why not? Well, number one, there might be data in your internal models that you don't want to expose, right? The other thing, which is possibly what's as important, is that as soon as you expose your internal models to external consumers via an API, for example, straight away you're creating a contract with them. And if you then want to start changing your internal models, which is entirely conceivable, and you should be able to do that, you may break the contract with your consumers. And you're basically tying your internal implementation to an external contract, which you absolutely do not want to do. So you need to abstract away your internal data from your external data. And that's all DTOs are. Okay, so they're very valuable, and that's what we're going to do next. All right, so back over in our application, make sure you've closed down any running services or anything like that, any running servers. And I'm going to do Control B to bring back up our Directory Explorer, and I'm just going to close down these windows here just to make it a bit nicer. And we are going to create yet another folder, so right click, new folder, and we're going to call this DTOs. And we're going to get our first DTO, new file, and I'm going to call this platform read DTO.cs. Now you might question this and go, what? Don't we just create one DTO? You could, but you're not really going to get the maximum benefit from them. We're going to create quite a few DTOs. In this section, just 2. So the use case is consumers are going to be reading data from us, platform data from our service. So this DTO, the read DTO, is going to be a representation of any data that we want to provide in that context when anybody's reading from us. The other scenario is going to be when somebody wants to create a platform using our service. We're going to provide a view of the data that we expect to be given in that scenario. And it's going to be very slightly different, okay? And that's where the real power of DTOs come in. Anyway, let's get on with this one first. So namespace, platform service, DTOs. And it's just a public class called platform read DTO. It's a very, very, very simple class. And I'm just double checking I'm spelling platform correctly. That looks good. Now what I'm going to do, I'm going to come over to our models folder, into platform, and I'm just going to copy all of our properties. I'm going to paste them in here. Okay. Now I don't mind doing copying and pasting in this instance because I've already typed this code out and I'm sure you don't want to see me double writing it out again. So let's take a look at these properties and think to ourselves, when somebody's reading data from us, is it conceivable that we would want to give them the ID of our platform object? Yes, we absolutely would. Would we want to give them the name? Yes, we would. Would we want to give them the publisher? This is where it starts going into, well, it depends what the intention of our API is. In this case, we're going to give it to them. And then cost, the reason I put this property in is really to kind of make the point that this could really be an internal bit of data that we don't ever want to expose. So again, if you didn't want to expose that, you would take it out. But for now, I'm just going to leave it in. May take it out later. We'll see how we go. So for the moment, our read DTO is going to be exactly the same as our platform DTO, and that's fine. But what it does mean is that you can change your internal platform model later, and this could remain exactly the same. Fantastic. All right, so that's all looking good. So we're going to create another DTO now. A little bit more interesting, new file. I'm going to call this platform create DTO.cs. Platform create DTO.cs. All right, great. So start with the namespace as usual. Platform service, DTOs. It's a public class called platform create. I'm typing too fast for my capabilities here. Platform create DTO. All right, fantastic. Now what I'm going to do, I'm going to come back over here and I'm just going to copy this again. But this time, let's think about the data that we've got here. So someone's going to create, this is for when somebody's going to, this is specifying the data we want when somebody's going to create a platform with us. The first property here, the ID, do we want them to give us the ID? No, in this case we don't, because we take care of that. Our database takes care of that by creating a primary key for us, and that's where the unique key comes from. So when someone's creating a platform with us, we do not want them to supply the ID as part of the body payload, so we take that out, okay? As for the other stuff, we'll leave that in, okay? Because we do want it. Now, let me just pop back over to the platform read DTO, and I actually took out the data annotations there. I should have mentioned that because it's a read DTO, I don't really feel that we need the data annotations in this case, so I'm just taking them out. For the platform create DTO though, I'm going to leave them in because out the box .NET does some nice data validation stuff with our controller actions. So if somebody doesn't supply one of these properties when they call our controller, .NET will go back with a nice pre-formatted error condition for us, which is really nice. So that's why I'm going to leave it in this case. So in order to use them, control period, and we'll bring in this namespace. All right, and that should clear up our errors, and we'll save that off. So yeah, platform read DTO, it's got all the properties. I'm just going to take out this double spacing, it's kind of annoying me. We've got all the properties that we had in our platform model. We're not using data annotations, but that's okay. And then our platform create, slightly different shape to it. We don't require the ID, but we are using data annotations. Fantastic. So that's our two DTOs done for this point in time. Now, at this stage, we've got our model, our platform model, and we have our two DTOs, but they're just separate classes. They don't know about each other. There's no way we can map at this point to them, but that's what we're going to do next. And we're going to use a tool called AutoMapper to allow us to map from one to the other. So we'll do that next. All right, so moving on to AutoMapper now, let's just clear down our development environment. And there's a few bits of setup required for AutoMapper. The first thing we should have already done, so over in your CSproj file, just double check that you have this package reference included at the top for AutoMapper. And if not, please add it, otherwise the next bit's not going to work. The next thing we need to do is register AutoMapper for dependency injection. So over in Startup, in our configure services method, we're going to do that here. So making use of our services collection once again, there we are, add AutoMapper at the top. And yeah, that should become a relatively familiar pattern that we're using. You can see it's complaining here because we do actually need to provide a little bit of extra detail inside the parentheses. So add domain, app domain, my apologies, current domain, and then get assemblies. And don't forget the parenthesis at the end there. And we'll save that off. So that's AutoMapper now registered in a dependency injection container so we can use it throughout the rest of our application. Now the final bit of this section is to create what's called a profile. So again, we've got our DTOs, we've got our models, they are not in any way mapped together, and we do that via a profile. So in the root of our project, right click, new folder, we're going to create a folder called profiles. And into that we're going to create a single class called platforms profile. So new file, platforms profile. .cs. Okay, and then the usual setup, the namespace of platform service, and this time it's profile. Profiles plural, and curly brackets, and then it's just a regular old class, so public class platforms profile. And we're going to inherit from an AutoMapper class called profile. Okay, now this has tripped me up a few times. Our folder is called profiles, our namespace is profiles plural. This class is profile singular. Okay, it's tripped me up a few times and caused me a few issues, so just make sure you get that correct and bring in the right namespace using AutoMapper. Fantastic, so that's our shell of our class setup. Now, where we create our mappings is actually in the class constructor. So just CTOR to do the shortcut for platforms profile, and tab across, and we just take out the parameters. We don't need any in there. So this is our class constructor, and it's in here that we create our mappings. So let's create our first map, and I'll talk you through about exactly what is happening. And before I do that, let me just do a little annotation, source to target. All right, so we use something called create map, and we specify the source. So think about a scenario where somebody is using our service to read data, consume data from us. Ultimately, that data, the source of it, is in our database. It becomes a model. Well, it is a model, a platform model. That's the source object. And we're going to then map that model to a platform read DTO and give the consumer the read DTO. So the source is the model, platform model, and the target is the read DTO. And that's what the mapping is. Now again, if this is a little bit abstract, when we come on to writing our controller, it will become a lot more obvious when we actually start putting it into practice. But for now, let's create our mapping. So platform, so this is our model, is the source. And let me just bring in the namespace for that before it starts, autocorrect starts driving me mad. So using platform service models, and then our target is platform read DTO. Close off the angular brackets and end with a parenthesis and a semicolon, and we'll just bring in that namespace. So again, just to reiterate, this is servicing our reading scenario. So the source of our data is our platform model, and the target is our platform read DTO. Now, a couple of important points here. Because our platform class and our platform read DTO have properties that are named exactly the same thing, and that's the way we want to map them, we don't need to tell AutoMapper anything else, hence the name AutoMapper. It does it for us, which is brilliant. When we move through the course, we're going to be creating other classes and other entities where that's not straightforward, and we have to then explicitly tell AutoMapper how to map or not to map between properties, but we don't need to do that yet. The second point is here that we've created a mapping with a source of a platform model to a target of a platform read DTO. Brilliant. If you then had another scenario where you needed the source to be a platform read DTO and the target to be a platform, you have to explicitly add that here. Just because we've created a mapping one way from those two objects doesn't mean that there's an implicit mapping the other way. You've got to explicitly add that, okay? Just those 2 points are pretty important. So just before we finish off, we'll create our last mapping, and this one is for the creation scenario. So again, in this instance, the source of the data is a platform create DTO, because that is what our consumers are giving to us. That is the source of the data. And the target for that ultimately is going to be the creation of a model down in our database, a platform model in our database. So the source is a platform create DTO and the target is a platform model. Okay, so create map once again, and our source this time is a platform create DTO and the target is a platform model. Make sure we get that correct. All right, and that's it for now. We will add more mappings in here with some rules as well, actually, but for now, that's all we need to service our current scenarios. So save that off, and the last thing I want to do, just before we move on to working with controllers, is just do a bit of a .NET run, just to make sure everything's running up and building okay. And if it is, we can move on to the next section. And it looks good, so let's move on to controllers. All right, so moving on to our controller now, I'm just going to stop our server from running. I'm going to kill the running terminal. And as usual, I'm going to clear down our previous work that we're doing just to make it look a little bit cleaner. All right, so we already have a controllers folder from when we scaffolded up the application, so we obviously don't need to create that. But right click on that, new file, and we're going to create a file called platforms controller. .cs. It's obviously a CS file. Fantastic. And then as usual, we define the namespace of platform service controllers. And then it's just a public class called platforms controller. We're actually going to inherit from something called controller base, which is really a base controller class that's really used for APIs as opposed to full-blown MVC web applications. So controller base. And we will have to bring in namespace, so control period, Microsoft ASP.NET Core MVC controller base. Oh, I selected the wrong option there. I want to, I did it again. Get it right this time. Using, here we go. My eyes were a bit crossed there. Oh, there we go. So we add the using statement at the top, that's what we want. Otherwise it's going to get way too busy. All right, so we're going to create a constructor, so CTOR, tab, and into this we are going to work with our repository, and we're going to eventually work with AutoMapper. So let's get going with that. So the first thing we're going to inject in is our platform repository. So what are we asking for? We're asking for an I platform repo. I'll just check that's what we called it. I know we just created it not so long ago, but I just want to make sure, I'm giving it the right name. So we're creating one of these, and that will be injected in. And we'll just call that repository. And then we're also going to request an instance of mapper, iMapper, which is our AutoMapper stuff, and we'll just call that mapper. And we'll need to bring in the namespaces for both of these. So using AutoMapper, and using, I think I might have, yep, there we are, spelt it wrong, platform, not platform, there we go. So try that again, that's better. Okay, now as usual, what we want to do is these two parameters are being injected. We want to assign them to private fields, usually denoted by an underscore. So we'll assign repository to underscore repository. There we go. And likewise for mapper. And we'll use these private fields inside our class. And of course they don't exist yet, so control period, and we want to generate a read-only field for each of them. And you can see they are added at the top here. Now this is the kind of very, very standard constructor dependency injection pattern that you're going to see lots and lots throughout this course. Constructor for a class will pass in a number of parameters, and then we'll assign them to private fields, private read-only fields that we then use within that class. Fantastic. Now the other thing we want to do is we want to actually decorate our class with a couple of attributes. The first one is API controller, and that gives us a lot of out-the-box functionality relating to API controllers, and I'll call those out as and when we come on to them, but it's mainly around passing through data via our actions and stuff like that, and yeah, sort of default behaviors that most web APIs will want to adhere to. So it saves us a bit of work. And then we want to also define our route, okay? And this is basically where we can find this API and then subsequent actions. So square brackets, route, open round brackets, and we're going to specify API / and then you can either specify explicitly the name of your controller, so for example platforms, or you can use this kind of wildcard approach where you can just put in square brackets controller, and that will take this portion of the controller's name, everything aside from the word controller, and basically put it in here, so you get the same result. So this route to this controller will be API / platforms. Okay, up to you which way you want to do it. I've seen it being used both ways, either using this way or just actually hard coding it, up to you. All right, fantastic. So now we want to come on to our first action, and in doing this first action, we can actually then test to see whether everything we've done so far has actually worked. So we're going to do an action that just gets all the platforms that have been added to our backend database. So public action result, it's of type IEnumerable. We're going to have to bring in that namespace, and it's an enumeration of, what is it? Enumeration of platform read DTOs. Okay, and let me just finish this method signature, and I'll just take you through exactly what we're doing here, just in case it doesn't make sense. And we'll call it get platforms. Okay, so we're not passing anything in, we're not passing in an ID in or anything like that. And yeah, that looks okay. And we're going to decorate it with a verb HTTP get. There we go. So let's save that off. Now, I think this, I'm surprised, I think I've made a mistake. Let me just put this other bracket in and then I'll probably get some complaints. Just finish that off. I'm surprised it's not, there we go. It's not complaining, it's complaining now, thankfully, about the fact that we didn't have IEnumerable or platform read DTO namespaces at the top. So let's bring those in. So control period, systems collections generic, and then platform read DTO. There we go. So basically what this is saying is when you call this action, and it's going to be get action at this route, API platforms, we're going to return an enumeration of our platform read DTO. Not our platform entity, not our platform model, but our platform read DTO, because we've said previously, whenever we're sending data out, we want to send over the the read DTO representation of our data. So that's why we're doing that. And then from there, it's actually relatively simple. And we're going to get to a point where we're almost ready to actually see that we've not made any mistakes throughout this whole build process to date. So just to help me debug if it's, if we have any issues, I'm just going to put in a console write line. I have to bring in the system namespace, so control period using system. And I'm just going to say getting platforms. And hopefully we get some platforms, but we will see. All right. So we want to now make use of our repository to actually go into a repository and pull back the platforms that we want. So I'm going to create a variable that will contain the return result set from our repository method. So platform items, and this is going to be an enumeration of platform models that our repository turns back. So we'll make that equal to, and we'll make use of our repository, and then we'll have a look, and we want to get all platforms, and we'll just do that. So that will go into our repository class. Let's come over here. It's going to use this get all platforms signature here, and then in our concrete implementation, it reaches in to our DB context and returns us a list of platform objects. Okay, so we have platform objects in here, but we want to return platform read details. So this is where AutoMapper comes in. We're going to map our models to our read details and return that back. And that might sound rather complex, but it's not really, thanks to AutoMapper. So we're just going to do a return. Okay, so HTTP 200 result, and then we're going to make use of mapper, our injected mapper object. So it's mapper, map, and what are we going to map to? We're going to map to an I enumerable of what? Let me just see if I can get rid of this thing, it's a bit annoying. An I enumerable of platform read details. There we go. And what are we mapping from? So this is what we're mapping to. We're going to map to an enumeration of platform read details. What are we mapping from? We're going to map from this collection here of models. All right, and that should be enough to basically get us at the result that we want. So if we just come back to our profiles and we have a look in here, basically that is going to be making use of this mapping construct here. Now, even though we're using an enumeration, doesn't matter. It's smart enough to know that enumeration on single objects, it will still work okay. So again, AutoMapper, very, very cool thing. So let's save that off. Let's do a control backtick and let's do a .NET run. And hopefully everything should be wired up correctly. I don't think I need to do anything with the platforms control. If we come back over, before we test this, we come back over to the startup class. Let me just move this down. Our controllers have already been added into configure services anyway, so everything should be wired up correctly, and our endpoints are all wired up down here in configure. You can see here we have our controllers mapped through, so should be okay. So the way I'm going to test it, I'm using a tool called Insomnia. If you want to use a web browser or you want to use Postman, Postman's obviously very popular, go for it, doesn't really matter. I like Insomnia because the interface is a little bit cleaner. It's just nicer for making videos. So I've got an empty environment here, and you can download Postman free off the internet. I'll put a link down below. I've got an empty environment, so what I'm going to do, because we're going to do a lot of testing throughout this, believe me, we're going to do a lot of testing in a lot of different environments. So I'm going to create a new folder, and I'm just going to call it local dev. So that's a local development environment, and I'm going to put all my requests for local development in here. And then I'm going to create another folder, and I'm going to call it platform service, because we're going to be testing a platform service and a few other things as well. So local dev platform service, and then we're just going to create a request, new request. I'm just going to go get all platforms. You can obviously call this anything you like, it's just a label really, and it's a get request, so create that. And where are we going to get our stuff from? Well, we're going to, if we come back over to our running application, and scroll up a little bit, you'll see that our application is listening on localhost 5001 for HTTPS and 5000 for HTTP. Now, in this video, I'm actually not going to work a lot with HTTPS, which is not something I would usually do, but for various reasons, more especially when we come to Kubernetes, it becomes very, very complex, and it's going to kind of distract us from the core of what we're focusing on. So for the most part, I'm going to be hitting the HTTP endpoints rather than HTTPS. Now that's something I might tidy up in future videos, but for the moment, I don't really feel it's too much of an inhibitor, especially not when we come to running things in Kubernetes. But it does come back to haunt us a little bit later on in the video when we come to using gRPC, but we'll cover that off when we come to it. So just wanted to call that out. Yeah, running on localhost 5000, 5001. For the most part in this video, we're going to just be working with HTTP to keep it simple. Otherwise, we start going down some rabbit holes. So let me just copy that, in fact, and I'll just paste that in and put that in over here. And then we want to put our route in, so it's API platforms, okay? So get request, here's our base URL, and then the route to our action. It's API platforms, which should look familiar to you. Now if we come back over here, it's basically what we specified up here at our class level. If I can find it. No, that's looking in the wrong looking startup. In our platforms controller, we come over here to our class. So our class level, this is our class level route, API platforms. And then we've specified a get. And so the method signature that we're calling from Insomnia will match this method signature here. There's no attributes being passed in or anything like that. So we should get a result back. So let's hit send. And indeed we do. So there we go. We get 200 response back and we get our 3 platforms returned, which should look quite familiar. These are the platforms that were injected into our in-memory database. So that's awesome. We're on the right track. So all we've got to do now is just finish off our last 2 controller actions, and then we're ready to move on to some of the more interesting stuff. All right, cool. So let's come on to finish off our controller. We'll finish it off for this section. We are going to add a lot more into it going through the course, but for now we're going to just finish off the basics and get our other 2 action results in place. So if, like me, your server's still running, just Control-C to take that down and get rid of the terminal. Don't need startup for the moment, and we're just going to work exclusively within our platforms controller class now. So what I'm going to do is I'm going to get rid of the sidebar, and I just pressed Control and B just to get rid of that, and you can toggle that on and off. We're not going to be moving around any of our files for this last section. We're just going to be working completely in here, so we can give ourselves a bit more breathing room and see exactly what's going on. So the next action I'm going to add in is going to be very similar to this, but this time we're going to request just one platform using an ID. So let's come on and get on and do that. So again, public action result. What are we returning? Rather than an IEnumerable, we're just returning a single platform. Read TTO. That's all. And I'm just going to call that get platform by ID. And then we are going to expect a parameter this time of type integer, and we're going to pass in an ID. Now, when I was talking about this API controller giving us some out-the-box behaviors, this is kind of what I'm talking about here. By defining this ID as part of an input parameter to this action result, basically that will be interpreted automatically when we come over to testing it, and we pass in /2 to relate to one of the IDs of the platforms. This route will basically be automatically interpreted by this to map to that. Okay, it's kind of nice. You can't explicitly tell what you're mapping through from your request, but in this instance, it's all doing this kind of stuff out the box for us. But of course, we do have to specify that it's a HTTP GET. Okay, and then it's actually very similar to this here. So the first thing we're going to do is declare a variable to hold our results. I'm going to call it platform item, singular this time because we're just looking for an individual item. And again, we'll make use of our repository class, and we did create a method in here called getPlatformsById. Fantastic. And what do we want to pass into it? We want to pass into the value that's been passed in through our URL. Okay, so we're going to attempt to get whatever was passed in. Now, as per sort of REST best practices, if you try to locate a resource, an individual resource, as we're trying to do here, and it's not found, you should return a 404 not found HTTP result set back. Okay, so that's what we're going to do next, or that's the kind of the check we're going to make. So if platform item doesn't equal null, then we have something, that's good, and we're going to return it back. So we'll return it back with an OK. And we're going to do something very, very similar as we did up here. In fact, almost identical. We just don't need to specify that it's enumeration. But let's type out anyway, because it's good practice to get across this stuff, because we're going to use AutoMapper quite a lot. So mapper, map, what we're mapping to. Instead of an enumeration of platform read details, we're just mapping to a singular platform read detail. And what's our source? It's this platform item. And that's it. Nice and straightforward. So if the platform item returned is not null, great, we do that. Otherwise, we're going to return not found result, and that will return a HTTP 404 for us. Fantastic. So let's save that off, bring up our command lines, do a .NET run, And remember, doing a .NET run also does a build for us as well, as you can see there. But I don't know why, I sometimes still like to run a separate build and then do a run. I don't know why, it's just my weird way of thinking. So let's run this one again. Let's take out the 2 and just make sure it's still working. There's no reason why it wouldn't be. Well, it isn't working. What have we done wrong? You've done something wrong here. Let's find out what we've done wrong. And we'll just scroll down a little bit. The request match multiple endpoints. Oh, I know what I've done wrong. So this is actually a really good example of something that we forgot. Well, I forgot to put in. You can see here we've got 2 HTTP GET requests, and it actually wasn't intelligent enough to, I forgot a really important thing. We actually have to specify an additional route in here, because otherwise what that error is saying is we've got 2 HTTP GET requests, which it interprets as being completely identical. It doesn't even get down to the method signature here, even though the method signatures are different. So bit of an omission there. So let me just rectify that. So within our HTTP decoration, let me just do open brackets. And what we're basically doing is we're specifying effectively a route, part of the route that we're looking for. So the way you do that is string, double quotes, curly brackets, ID. So we're saying we are expecting, as part of this GET request, an ID. And as part of that, that is then mapped into this. Yeah, that's my bad. You really forgot to mention that. So yeah, as part of this route here, if we do this, 23 for example, it's going to match this route here. If we take this out, then it's going to match this route here. And it was getting confused because we had no point of differentiation. And where API controller comes in is it automatically maps this value into here. There you go. Early in the morning for me here, I'm not quite woken up yet. Now, the other thing we're actually going to do while we're doing this, I'm actually going to give this a name, and you'll see how this comes into play in the next short while. And I'm just going to give it exactly the same name as the method signature name. Okay, and we actually make use of this a bit later on in our next action result. Okay, cool. There we go. So that should be okay now. So let me run that up again. Control C and run it up again. And let's see how we're going. So let's come back to Insomnia and let's just run our old request. There we go, back to normal. That's cool. And then we're going to create a new request explicitly for get a individual platform. Okay, there we go. And what I might do is I might just copy this over, and I'm going to paste that in here. And let's have a look at our result set over here. So you can see the in-memory database has automatically added IDs for us. Fantastic. So let's see if we can pull back Kubernetes, since we're going to be working with that next, and put in 3. And indeed it does, it pulls back the individual platform for us, which is all good. Now if we put in some ID that doesn't exist, we'll get a 404 not found, which is exactly what we want, and that kind of adheres to our REST kind of standard practices. Fantastic. Okay, good. So I'm actually quite glad I had that error, honestly I am, because it kind of helps you understand how things work. And that's a really good point. When you make mistakes and when things don't work, that is actually, for me personally, that's when I learn stuff. If everything just goes totally smoothly all the way through, you're going to learn stuff, but not as much as when things go wrong. Okay, so this is a long course. I'm just going to call this out here. This is a long video. You're going to make mistakes. I guarantee it. I guarantee you're going to make typos here. You're going to forget to put things in there and things are not going to work. Don't stress out about that. The code is available on GitHub, and you can, if you want to, you can just kind of overlay that on what you're doing. But what I would suggest you do is try and fix it, because in trying to fix it, you're going to learn a lot more than just listening to me talking and going through the video. All right. So rant over. We're going to move on to our last action result, which is creating a platform using our controller. And then we're going to move on to a bit of Docker and then Kubernetes. All right, so let's come on to creating our third and final controller action in our platform's controller. And it's this controller that we're going to use to create platforms in our backend database. And it's this controller that's going to be the one that we're going to return to and do a lot more work in terms of triggering messaging to other services. So we're not done with this one fully yet, but we're going to get it into a state where we're creating platforms and then we're going to move on to something else, but we will return. So before we do that, let's just do a Control-C to kill the running server, get rid of this, and then we'll move down and we'll create our final action. So again, public action result. And what we're going to return back, we're actually going to return back a platform read DTO. So when you create a platform